So mathematically, quantization of charge may be stated like this. The net charge on a body must be given by some integral multiple of smallest unit of charge. This is an integer. Positive value when the body is positively charged. Negative value when it will have excess of electrons or it is negatively charged. So plus minus. So this is the mathematical form of quantization of charge. There are various short type questions based on this particular formula. Let's take a simple example. Let's take the example of glass rod and silk only. Just now I've stated, when glass rod is rubbed with silk, glass rod tends to lose electrons, silk tends to gain electrons. Now, in order for a glass rod to acquire charge of 1 microcoulomb, coulomb is the SI unit of charge, that also we need to discuss. But again, for a glass rod to acquire a positive charge of 10⁻⁻6 coulomb, how many electrons need to get transferred from glass rod to silk? Right? Again, I'm repeating the question. Calculate the number of electrons that are transferred from glass rod to silk for the glass rod to acquire charge of 1 microcoulomb. So let's solve this example. So, as per the quantization charge, we are aware Q equals to N. N is the number of electrons that are transferred, isn't it? So N would be equal to Q by E. So what is the total charge acquired by the glass rod? It is 10⁻⁻6. What is the value of E? It is 1.6 into 10⁻⁻19. It is considered the smallest unit of charge, right? So we can easily solve it. So it will be 10 by 16 into 10 raised to power. It will be minus or rather plus 13. So if you solve it, so it will be approximately 100 by 16 into 10 to the 12. So 6.25 into 10 to the 12. Just imagine, after the transference of these electrons from glass rod to silk, the glass rod will acquire a positive charge of plus 10⁻⁻6 coulomb, while the silk will acquire a negative charge of minus 10⁻⁻6 coulomb. Same, both will acquire equal and opposite charge, right? So, due to the transference of electrons, these number of electrons, the glass rod will acquire this charge. Let's deal with another example. Suppose a body is having a negative charge of 1 coulomb. So what do you mean by this? Obviously, since the body is having a net negative charge, it must be having excess of electrons. Can you count the number of electrons, number of excess electrons residing in that particular body? Again, my question is, if a body possesses a charge of minus 1 coulomb, then how many excess electrons are present in that particular body? So again, make use of this formula. Number of electrons will be Q by E. So you can easily solve it. 1 divided by net charge in the body is 1, magnitude. And the smallest unit of charge in magnitude is considered to be 1.6 into 10⁻⁻19. I think you can easily solve it. So we get 10 by 16 into 10⁻19, or we can write it like this, 100 by 16 into 10⁻18, or it would be 6.25 into 10⁻18 electrons. This is also a very, very important result. So 6.25 into 10⁻18 electrons will constitute a charge of 1 coulomb. If a body is losing this much electrons, it will acquire a net positive charge, plus 1 coulomb. If a body is having this much excess electrons, it will have a charge of minus 1 coulomb. Which are another very, very important conceptual question. In several competitive exams, or rather, conceptual question, it might be asked, is there any change in the mass of a body when the electrons get transferred from one body to another? The answer is definitely yes. there's a minute change, very, very negligible change in the mass, but there is obviously a change, right? So basically, listen carefully. During rubbing, as I've told you numerous times, what happens is the electrons get transferred from one body to another body. Electron, it's a particle. It possesses some mass, although it's negligible, but it possesses a mass of 9.1 into 10 to the minus 31 kg. So what happens is when the electrons get transferred from one body to another, the body that loses electrons, obviously it is losing matter as well. While the other body that is gaining electrons, that is gaining matter. So the body that acquires a net negative charge, its mass will slightly increase. While the body that acquires a net positive charge due to loss of electrons, its mass will slightly decrease. Understood the concept now? So obviously there is a change in the mass during the transference of electrons from one body to another, although it is marginal, but still there is some change in the mass. The body which acquires a net positive charge, its mass will slightly decrease, while the body that acquires a net negative charge, its mass will slightly increase, right? So we were dealing with the properties. So this was a very, very important property. We have discussed conservation of charge, we have discussed quantization of charge. Then you are aware, charge is additive in nature. Charge is additive in nature. What I mean to say is that, suppose there's a body and these are the different parts. Suppose it possesses a charge of plus 2e, it possesses a charge of minus 4e, it possesses a charge of plus 5e, it possesses a charge of plus 10e, and it possesses a charge of minus 2e. So this is suppose Q1, Q2, Q3, Q4, Q5. Charge is a scalar quantity, so it needs to be added algebraically, isn't it? Additive nature means net charge on the body would be given by the sum of the charges which are present in various parts of this particular body. That is plus 2e plus minus 4e plus 5e plus minus 2e plus 10e. So you'll get the answer. So charge is additive in nature. So any body which is constituting charges of Q1, Q2, Q3, Q4, Q5, Q6 and so on its different part. So net charge on that particular body would be given by Q1 plus Q2 plus Q3 and so on. This is the algebraic sum. This is the algebraic sum. Charge is a scalar quantity. This also we'll discuss later on. So charge is a scalar quantity. So this is again a very, very important property, right? So, three properties which we have discussed. Charge is conserved, charge is quantized, charge is of additive nature. Then there is another property, invariance of charge. Invariance of charge. Invariance of charge